All right, so this is your setup for the electrochemistry lab. First thing you want to do is turn on your voltmeter so that we see a reading. Now there's going to be two leads that we're going to work with today, a red lead and a black lead. And you want to plug the red lead into the center port of the voltmeter and the black lead into the bottom port of the voltmeter. Now the last component to the voltmeter is the maximum voltage setting. There's three of them. 20 volts, which would be the maximum setting, 2000 millivolts, or 200 millivolts. Now we're going to get some readings around 1500 millivolts, so we're going to use the 2000 millivolts maximum setting for our voltmeter. Okay, so once your voltmeter is set up, we first want to do the battery test. So what you'll do is take the red lead and place it on the positive end of the battery, and then take the black lead and place it on the negative end of the battery. And we see that we get a reading on our voltmeter of 1625 millivolts. Now that number isn't significant, but what is significant is the fact that we get a positive reading. If we switch our leads and now place the black lead on the positive side of our battery and the red lead on the negative side of our battery, we get roughly the same value on our voltmeter, 1625, but this time the sign is flipped. We get a negative reading. So this is the most important part to remember for your lab today. If you get a positive reading on your voltmeter, that means the red lead is on the cathode and the black lead is on the anode. Okay, so let's go ahead and start connecting our leads to our different metals. This is the well plate that you'll be working with today in lab. The first thing you want to do is place the potassium nitrate solution into the center of the well plate, and that will be contained by the solid salt bridge. This will allow electrons to flow between the different cells. Each well will contain an aqueous metal solution and a solid piece of corresponding metal. So for example, we placed our aqueous iron 3+ nitrate solution in the top well here, and then what we'll do is place a solid iron metal piece into that solution. Now you'll do the same thing with the other metal solutions available. You're going to have a silver well, a copper well, a lead well, a zinc well, and a magnesium well. Now when you fill your well, you want to add just enough solution so that it overfills the well and comes in contact with the solid salt bridge. Okay, so let's connect our leads to our first pair of metals. We're going to keep the black lead, which is connected to these alligator clips, on our zinc metal. So the black lead will be on the zinc metal, and then the red lead we'll place starting off on our copper metal. And let's see what sort of a value we get. Looks like we get about 846 millivolts. And remember, importantly, that number is positive. Okay, so let's switch our red lead. We're going to keep our black lead on the zinc well, but switch our red lead to iron. And this time we get a value of roughly 1350. Now, sometimes the voltage will continue to drop, so it's important that you write down the number that you first see on the voltmeter. All right, so finally, let's place our red lead on the magnesium metal. And it looks like we're getting a voltage of 460, but importantly, this is a negative value. Now there's a lot of different combinations of metal that you'll test out in lab. These are just a few of them. But once you measure potentials for all metal combinations, then we'll begin to write balanced half reactions and come up with a trend of reduction potentials.